is now anticipated in the
as the
2026.
largest aircraft manufactured by the company. The C-390-30 has a wingspan of 14.7 meters.
Frustration is growing among the airlines over the delay of the Boeing 777X program. The aircraft's entry into service has been repeatedly postponed due to engine issues, design changes, the COVID-19 pandemic, and regulatory challenges. These setbacks have forced some airlines to revise their fleet plans and express their dissatisfaction. Boeing is actively working to address this issue, but ongoing delay continues to strain relations with its airline customers.
Whereas the 5,000 millennium 77,000 at 35 higher maximum takeoff 100 allows it to carry a slightly greater payload, including fuel.
Thanks for watching. Please share your thoughts.
Share your thoughts about Boeing 777X aircraft in the comment section.
806 miles
140. The Su-30 achieves, while the C-390 Millennium has a wingspan 20 kilometers per hour, 1,320 at high altitude, while the J-16s has maximum speed is the C-2 Kawasaki, which is powered by 400 General Electric CF680 1,500 miles per hour turbofan engines, each providing 265.7 kilonewton of thrust. The Su-30 revolutionized 390 3,000 utilizes two 1,900 E5 turbofan engines, each generating 139.4 kilonewton of thrust. The C-2 Kawasaki has higher a maximum takeoff weight of 188 kilometers per hour, 614 miles per hour. According to the most recent updates, the Kawasaki C2 will cost approximately $240 million, and the KC-390 will cost approximately $161 million. The C2 Kawasaki offers a range of 7,600 kilometers, 4,700 miles, with a 20-ton payload compared to the C390 Millennium, which has a range of 5,020 kilometers, 3,120 miles, with a 14-ton payload. The C2 Kawasaki can reach higher service ceiling of 13,100 meters, 43,000 feet, whereas the C390 Millennium has a lower service ceiling of 11,000 meters, 36,000 feet. The Kawasaki C2 has formally entered service with the Japan Air Self-Defense Force, and efforts to sell it to countries such as New Zealand and Middle East. In April 2024, Japan's Kawasaki Heavy Industries will start promoting its C2 heavy transport aircraft to Middle Eastern markets. The KC-390 made its maiden flight in 2015 and has since entered service with the Brazilian Air Force. It has also been ordered by the Portuguese Air Force and the Hungarian Air Force. The aircraft has been praised for its versatility and cost-effectiveness, and is expected to compete with other medium-sized military transport aircraft, such as the Lockheed Martin C-130J and the Airbus A400M. To decrease the obstacles of flying at low altitudes or near rugged terrain, a tactical flight management system and a head-up display are installed. The C2 has a full glass cockpit, fly-by-wire flight controls, high-precision navigation, and self-protection systems. KC-390 has a modern cockpit with advanced avionics and fly-by-wire controls, which enhance safety and reduce pilot workload. It also has a self-defense system, including a radar warning receiver, a missile warning system, and chaff and flare dispensers. Kawasaki C2 has cargo deck of the aircraft, is designed to hold up to 36 tons of equipment or 110 personnel. It is equipped with weight sensors, surveillance cameras, electronic bulletin boards, and an automated loading and unloading system to enhance operational efficiency. The KC-390 is equipped to refuel both fixed-wing and rotary-wing aircraft. Additionally, it has an on-ground refueling capability that allows it to refuel vehicles or support forward operating bases. Each aircraft is the pinnacle of its class and of technology. However, size does matter. The Kawasaki has a far greater range and cargo capacity than the KC-390 aircraft. Comparing the two aircraft, the KC-390 is less expensive than the C-2, making it more accessible to developing nations. Thanks for watching. Please share your thoughts about both aircraft in the comments section. Two aircraft have emerged. The Sukhoi Su-30, a derivative of the Su-27 flanker, is renowned for its versatility, with its origins rooted in the Cold War era and extensive upgrades over the years. In contrast, the J-16, developed by China's Shenyang Aircraft Corporation, represents the latest in China's growing aerospace prowess, boasting advanced systems. In this video, we will compare both fighters, examining their design, technological advancements, and operational capabilities to understand how they stack up against each other in the competitive landscape of modern aerial warfare. Meet the Sukhoi Su-30, a powerful and versatile Russian fighter jet that stands out in the skies. With its twin-engine design and tandem seating for two pilots, the Su-30 is a marvel of modern military aviation. It's designed to fly in all weather and perform air-to-air and ground attacks. It can fly with autopilot and use radar to navigate at low altitudes. As of 2024, about 600 of these jets have been built. While Shenyang J-16 is a Chinese fighter jet that also has 2 seats and 2 engines. Made by China's Shenyang Aircraft Corporation, the J-16 is used by the Chinese military and is known for its advanced technology, including a version that uses artificial intelligence in place of a backseat pilot. As of 2024, around 350 J-16s have been built. Russian Su-30 and the Chinese J-16 are advanced multi-role fighters, with notable differences. The Su-30 measures approximately 21.935 meters, 72 feet, in length, while the J-16 is slightly shorter at around 20.3 meters, 66.7 feet. The Su-30 has a wingspan of 14.7 meters, 48 feet, which is marginally wider than the J-16, which has wingspan of 13.8 meters, 45 feet. The Su-30's has maximum takeoff weight is 34,500 kilograms, 76,059 pounds, while the J-16 can reach up to 35,000 kilograms, 77,000 pounds. Higher maximum takeoff weight allows it to carry a slightly greater payload, including fuel and ordnance. The Su-30 achieves approximately 2,120 kilometers per hour, 1,320 miles per hour at high altitude, while the J-16's has maximum speed is slightly higher, which is 2,470 kilometers per hour, 1,540 miles per hour. The Su-30 has a range of about 3,000 kilometers, 1,900 miles, which is greater than the J-16's range, which has approximately 2,500 kilometers, 1,550 miles, with external fuel tanks. The Su-30 operates up to a service ceiling of 17,300 meters, 56,800 feet, while the J-16 has a higher service ceiling of approximately 20,000 meters, 65,600 feet. The Su-30 is powered by two Saturn AL-31FL or FP engines, each producing 74.5 kilonewton, 16,700 pounds force of thrust. In comparison, the J-16 is powered by two Shenyang WS-10B engines, provide 135 kilonewton, 30,000 pounds force, offering greater thrust for enhanced performance. The Su-30 and J-16 are both equipped for multi-role operations, with the Su-30 featuring a variety of Russian-made air-to-air and air-to-ground missiles, and the J-16 carrying Chinese-made PL-12, PL-15, and PL-21 missiles, as well as KD-88 precision-guided munitions. The Su-30 features autopilot capability throughout all flight stages, including low-altitude operations using terrain-following radar. It supports both individual and group combat against air and ground or sea surface targets. Outwardly, the J-16 features sleek and smooth lines, reminiscent of the Sukhoi Flanker series, with a few distinct external differences. The aircraft is equipped with a special radar-absorbent coating on its skin, enhancing its stealth characteristics, though it remains detectable by modern radar systems. Internally, the J-16 boasts an advanced, indigenously developed ESA active electronically scanned array radar system. The Su-30 is renowned for its robust airframe, exceptional maneuverability in all axes, and its iconic Cobra maneuver. The tactical effectiveness of the Cobra maneuver has been a topic of debate for decades, with no clarity its practical application. Designed originally for ground attack roles, the series incorporates features such as canards, thrust vectoring engines, and a long-range phased array radar to excel in air superiority missions. The J-16 represents China's push towards integrating autonomous capabilities in its combat aircraft. Notably, a variant of the J-16, reported in March 2021, replaces the rear seat pilot with an artificial intelligence system, known as Intelligence Victory, reflecting China's advancements in AI for military applications. Thanks for watching. Please share your thoughts about both fighter aircraft in the comments section. In the evolving realm of advanced military aviation, two aircraft stand as symbols of their respective nations' ambitions. India's Advanced Medium Combat Aircraft AMCA, and the United States' F-35 Lightning II. The AMCA, still in the development phase, embodies India's strategic vision for a homegrown, cutting-edge fighter jet designed to meet future combat challenges. On the other hand, the F-35, an already operational marvel of American aerospace engineering, has set the standard for modern stealth and multi-role versatility. In this comparison, we will delve into the two different fighters, the AMCA and the F-35, examining their technological innovations, strategic roles, and potential impacts on global air combat dynamics. The AMCA is an advanced Indian fighter jet featuring a single-seat, twin-engine design with all-weather capabilities and fifth-generation stealth technology. It is being developed for both the Indian Air Force and the Indian Navy, aiming to enhance India's combat prowess with its multi-role versatility. In contrast, the Lockheed Martin F-35 Lightning II represents an American family of single-seat, single-engine stealth aircraft, known for its air superiority and strike mission capabilities. The F-35 also excels in electronic warfare and offers advanced intelligence, surveillance, and reconnaissance functions. Here is comparison between the two aircraft. The AMCA measures 17.6 meters, 57 feet in length, while the F-35 is slightly shorter at 15.7 meters, 51.4 feet. The AMCA stands at 4.5 meters, 14 feet in height, whereas the F-35 is marginally taller at 4.4 meters, 14.4 feet. The AMCA wing area is 590 square feet, whereas the F-35 has a significantly larger wing area of 460 square feet. The AMCA estimated maximum takeoff weight is 25,000 kilograms, 55,116 pounds, compared to the F-35, which has the higher maximum takeoff weight of 29,900 kilograms, 65,918 pounds. The AMCA has a fuel capacity of 6,500 kilograms, 14,300 pounds, while the F-35 carries slightly higher fuel capacity, which is 8,278 kilograms, 18,250 pounds of internal fuel. The AMCA can achieve higher maximum speed of 2,600 kilometers per hour, 1,600 miles per hour, whereas the F-35A reaches a maximum speed of 1,296 kilometers per hour, 806 miles per hour. The AMCA can reach a service ceiling of 20,000 meters, 65,000 feet, while the F-35A operates slightly lower at 15,000 meters, 50,000 feet. Recently, India's Advanced Medium Combat Aircraft AMCA program is set to revolutionize its production process with 3D printing technology. By integrating 3D printing, HAL anticipates substantial benefits ranging from cost reduction and faster turnaround times to optimized material usage. The adoption of 3D printing not only promises to streamline production, but also offers opportunities to mitigate material waste, a critical challenge in aerospace manufacturing. The F-35A design is robust, in contrast to its 8,000-hour design life. Its service life has been evaluated to reach 24,000 hours. The F-35 has an extremely low radar cross-section, at 3.8 millimeters, which reduces its radar profile. Multiple software and processor updates have been made to the F-35A. Progress includes improved weapon capability and electronic warfare systems. The current version, known as Block 3F baseline, is moving towards Block 4 with software and weapon improvements planned twice yearly in 2024. The AMCA is currently being developed and will have sophisticated avionics, including an electronic pilot function. A fighter platform typically needs two pilots. One is a pilot who flies, while the other is a mission pilot who directs the flying pilot, as a way to improve situational awareness and collaborate with the Advanced Electronic Warfare Suite. On board the AMCA, distributed passive sensors with AI-assisted multi-sensor data fusion are anticipated. The F-35 Lightning II features a single-seat cockpit with advanced automation and AI, enabling the pilot to handle both flying and mission-critical tasks. Its distributed aperture system offers a 360-degree view, enhancing situational awareness. Supported by an advanced electronic warfare suite, the F-35's AI-driven sensor fusion integrates data from various sensors, providing a complete battlefield picture. This technology reduces the pilot's workload and significantly boosts the aircraft's combat effectiveness. Since HAL realized the primary goals and advancements needed for AMCA for future aviation projects, when constructing aircraft, in collaboration with international suppliers and via innovative research for newer weapons, the defense is advancing its weaponry. The BrahMos air-to-ground missile, Astra, Rudram, laser-guided, and precision munition pods will all be made available by the AMCA. Radar and infrared search and tracking features are some additional elements that aid aircraft detection. The F-35 features 2 internal weapon bays and 4 weapon stations. There are air-to-air missiles at the 2 inboard weapon stations. Among the air-to-surface weapons for the outboard station are the Joint Direct Attack Munition, the Paveway line of bombs, the Joint Standoff Weapon, and cluster munitions. The AIM-9X or AIM-132 can be mounted in a high-stakes maneuver to secure a pivotal defense contract. The Pentagon is intensifying its efforts to promote the F-15EX fighter jet, a powerhouse of American engineering. This push is aimed at securing a key position in India's highly competitive multi-role fighter aircraft, or MRFA deal, that could change the dynamics of the global defense market. The U.S. is making a major effort to reverse the more than 70-year trend of American fighter jets failing to find a home in the Indian market. The F-21 is perceived as a slight improvement over the F-16V, and Pentagon officials are aware that the Indian Air Force has been hesitant to adopt it. This hesitation was made clearer when the U.S. lost the contract to supply the Indian Navy with fighter jets mounted on carriers to the French Rafale M. A vital opportunity for the U.S. to get into the IAF's fighter jet lineup is now presented by the MRFA tender. Despite the challenges, the Pentagon believes the F-15EX has strong potential. the IAF has shown some interest in the F-15EX due to its proven track record and advanced capabilities. However, the competition is stiff and the IAF selection process is rigorous. On the other side, United Arab Emirates has unexpectedly canceled its $20 billion agreement with France for the purchase of 80 Rafale fighter jets, a decision that has sent shockwaves through the global defense industry. The cancellation follows the brief detention of Pavel Durov, the CEO of Telegram, by French authorities, an incident that has strained diplomatic relations between the UAE and France, despite Durov's subsequent release on bail. France had viewed the Rafale deal as a cornerstone for boosting its defense industry, with significant implications for both economic growth and international standing. The freezing of this contract represents a major setback for French president, who had championed the deal as a symbol of France's strategic partnership with the UAE. The decision also delivers a blow to Dassault Aviation, the manufacturer of the Rafale jets, which now faces uncertainty regarding future orders. The UAE's cancellation of the deal is seen as a clear message that geopolitical tensions can rapidly influence major business agreements. Analysts are closely monitoring the situation for any further developments, particularly as this decision may affect other nations considering similar deals with France. Thanks for watching. Please share your thoughts in the comment section.
Hello everyone and welcome back to Jetline Marvel. Boeing's highly anticipated next generation wide-body, the 777X, is facing yet another setback. The company has been forced to pause the flight test and ground its end test fleets. The disruption comes after the Boeing discovered structural damage in one of the 777X aircraft. The issue was found in custom component located between the engine and the aeroplane structure. On Monday, Boeing announced that during routine maintenance, they identified the damage and decided to halt all flight tests for the 777X fleet. As a precaution, the company has grounded the three 777-9 test aircraft, even though no additional flight tests were immediately planned. Boeing is currently replacing affected parts and conducting an in-depth analysis to prevent future occurrences. In comparison to the Airbus A350, 777-9 stand out with a maximum fuel capacity of 158.9 tons, offering 34 tons more than the A350, that is 124.65 tons. Boeing has already notified the Federal Aviation Administration and its customer, who have collectively placed 481 orders for the 777X aircraft. This grounding raises concern about the potential impact on the aircraft certification and delivery timeline. Originally expected to be delivered in 2025, the 777X program is now about 5 years behind the schedule. The aircraft, which began test flight with the FAA in July, is a crucial Boeing's efforts in advancing next-generation aircraft technology. This delay comes at a challenging time for Boeing, as the company is still recovering from safety crisis earlier this year involving door plug blowout. Under the new leadership of CEO Kelly Othberg, Boeing is navigating these difficulties as it works to rebuild trust and stability. The 777X program includes both passenger and freighter variant with a significant order from the major airlines such as Emirates, Qatar Airways, Cathay Pacific, and Singapore Airlines, Lufthansa, and Korean Air. However, no US airline has placed an order for 777-9 so far. The first delivery, which was initially set for 2020 and recently pushed to 2025, is now anticipated in the 2026. Frustration is going among the airlines over the delay in the Boeing 777X program. The aircraft's entry into service has been repeatedly postponed due to engine issue, design changes, the COVID-19 pandemic, and regulatory challenges. These setbacks have forced some airlines to revive their fleet plans and express their dissatisfaction. Boeing is actively working to address this issue, but ongoing delay continue to strain relations with its airline customer. Share your thoughts about Boeing 777X aircraft in the comment section.
Military cargo planes have emerged. Brazil's Embraer KC-390 and Japan's Kawasaki C2. In this video, we'll take a look at two different aircraft. The Brazilian-built Embraer KC-390 and the Japanese-built Kawasaki C2. We will comprehend aircraft, specifications, and their best possible flying and serving capabilities for military needs. The Kawasaki C2 is a high-speed, long-range military transport aircraft, featuring a mid-size design with twin turbofan engines. Developed by Kawasaki Aerospace Company, the C2 was created alongside the PX Maritime Patrol aircraft. To optimize costs, Kawasaki utilized shared airframe parts and system components between the C2 and the PX. The Embraer C-390 Millennium is a medium-size, twin-engine military transport jet developed by the Brazilian aerospace manufacturer Embraer. As the largest aircraft produced by the company, the C-390 Millennium project began in the mid-2000s. Initial design concepts were based on a derivative of the E-190 jetliner, aiming for a similar size to the Lockheed C-130 Hercules. Here is a detailed comparison of the C-2 Kawasaki and C-390 Millennium. The C-2 Kawasaki measures 43.9 meters, 144 feet in length, whereas the C-390 Millennium is shorter, at 35.2 meters, 115 feet. The wingspan of the C-2 Kawasaki is 44.4 meters, 145 feet, while the C-390 Millennium has a wingspan of 35.05 meters, 115 feet. The C-2 Kawasaki is powered by two General Electric CF680C2K1F turbofan engines, each providing 265.7 kN of thrust. In contrast, the C-390 Millennium utilizes two IAE V2500 E5 turbofan engines, each generating 139.4 kN of thrust. The C2 Kawasaki has a maximum takeoff weight of 141,400 kilograms, 311,734 pounds, while the C390 Millennium has a maximum takeoff weight of 86,999 kilograms, 191,800 pounds. The maximum speed of the C2 Kawasaki has 920 kilometers per hour, 570 miles per hour, whereas the C390 Millennium is slightly faster, with a maximum speed of 988 kilometers per hour, 614 miles per hour. According to the most recent updates, the Kawasaki C2 will cost approximately $240 million, and the KC390 will cost approximately $161 million. The C2 Kawasaki offers a range of 7,600 kilometers, 4,700 miles, with a 20-ton payload compared to the C390 Millennium, which has a range of 5,020 kilometers, 3,120 miles, with a 14-ton payload. The C2 Kawasaki can reach higher service ceiling of 13,100 meters, 43,000 feet, whereas the C390 Millennium has a lower service ceiling of 11,000 meters, 36,000 feet. The Kawasaki C2 has formally entered service with the Japan Air Self-Defense Force, and efforts to sell it to countries such as New Zealand and Middle East. In April 2024, Japan's Kawasaki Heavy Industries will start promoting its C2 heavy transport aircraft to Middle Eastern markets. The KC390 made its maiden flight in 2015 and has since entered service with the Brazilian Air Force. It has also been ordered by the Portuguese Air Force and the Hungarian Air Force. The aircraft has been praised for its versatility and cost-effectiveness and is expected to compete with other medium-sized military transport aircraft, such as the Lockheed Martin C-130J and the Airbus A400M. To decrease the obstacles of flying at low altitudes or near rugged terrain, a tactical flight management system and a head-up display are installed. The C2 has a full glass cockpit, fly-by-wire flight controls, high-precision navigation, and self-protection systems. KC390 has a modern cockpit with advanced avionics and fly-by-wire controls, which enhance safety and reduce pilot workload. It also has a self-defense system, including a radar warning receiver, a missile warning system, and chaff and flare dispensers. Kawasaki C2 has cargo deck of the aircraft is designed to hold up to 36 tons of equipment or 110 personnel. It is equipped with weight sensors, surveillance cameras, electronic bulletin boards, and an automated loading and unloading system to enhance operational efficiency. The KC390 is equipped to refuel both fixed-wing and rotary-wing aircraft. Additionally, it has an on-ground refueling capability that allows it to refuel vehicles or support forward operating bases. Each aircraft is the pinnacle of its class and of technology. However, size does matter. The Kawasaki has a far greater range and cargo capacity than the KC390 aircraft. Comparing the two aircraft, the KC390 is less expensive than the C2, making it more accessible to developing nations. Thanks for watching. Please share your thoughts about both aircraft in the comments section.